The TLDR on this is that there were a couple of bad solder joints and a battery holder making poor connection. It's a Christmas decoration that you're supposed to stake in your front lawn if you have one. It costs $15 and has 15 LEDs. It has a sign with a frame holding the LEDs. The sign has a matte finish translucent sheet of Santa on each side. The sign wires to a box containing solar panels, the battery and a control board. The package comes with a pole for the sign, a stake for the sign, and a stake for the solar panel control box. The battery is 1.2 volt, 600 milliamps, IP44 rated. The nickel metal hydride. Here's the sandwich, the LEDs between the sheets of Santa. There's like 15 of them wired in parallel, daisy chain one to the next. The control board on box on the back has off or flash or on for the LEDs. There's a few solar cells. And there's where the solar panels wiring over to the control board sort of tucks in behind there, and so I'll be measuring there in a moment. Shinjol nickel metal hydride, 600 milliamps, 1.2 volts. Measuring 1.6 volts when I've got the flashlight of my phone shining on the solar cells. That's where I was measuring. But the battery wasn't receiving any charge at that point, and I'm pretty sure it was because of that poor solder joint there. So soldered that up, and then the battery was receiving, well, you see the battery compartment when it's face down receiving nothing at the moment. And then if it's face up, just in some ambient light, lamp light, getting 0.9 volts. Checking out the battery itself, it was okay. 1.2 volts, I guess. Since the sign had stopped, it must have received some charge, and but then something else wasn't using the charge in the battery because something else was busted. The controller board runs on a chip, which is a dedicated chip for solar panel driven LED lights, YX861A. You can get these from AliExpress, $8.45 per 20 pieces, free shipping, in a DIP 8 package, SOP 8 package, eBay, $4.17 Australian plus postage. This is from the datasheet. Datasheet's mostly in Chinese. LED drive, pin, ground, input for the battery, input for the solar panels. Modulation pin is the switch for on or flashing. TSET1, TSET2 are resistors for setting the frequency and duty cycle, and a VDD pin output. And there we have on the right the solar panel, the battery, the inductor going from the battery to the LX output, where that's going to be banging away at the inductor, and then the LED there representing the string of LEDs, and then on the left hand side VDD, a couple of resistors there for setting the frequency and duty cycle, and modulation switch for on or flashing. This is the 1.25 volt version, which is the one that I've got. But the datasheet also has a 2.5 volt version of the schematic, which is different in that the solar panel's got more cells, battery's got more cells for 2.5 volts, and the transistor there is going to be using the battery as the voltage reference, and then just boosting, well, not boosting, but using the current from the inductor. From the data sheet, this is the frequency and duty cycle notes for R1 and R2. With those 47Ks, you've got 1.1 Hertz and 50% duty cycle, I guess. And if you want something different, I guess you got to play around with R1 and R2 for different frequencies and duty cycles. Some notes there for the current output that you might require, depending on what sort of LEDs you've got or how many you've got, and what value inductor you're going to need. And that's where the inductor is. It's a little RF choke inductor mounted under the board. Can't quite tell what the colors were, so I'm not exactly sure what the value of that one was. It's got a rubber gasket around the side, and the screw stumps kind of insert into each other. So it's not completely waterproof, but it's okay. And a bit of Celastic there. This is the output from the LED drive pins, the wires going to the sign. Multimeter's averaging at 1.2 volts, but if you look at it on the scope, we've got 2 volts per division, so it's about 5 volts, or 5 to 6 volts peak to peak there, but 80 milliseconds, I guess we're getting I don't know, 160 milliseconds on, 160 milliseconds off, something like that. That was in the flashing mode. This is in the steady mode, looking at 80 microseconds there. And the frequency shown here may not be quite exactly the correct frequency because the trigger point there was in the noise a bit. Would have been better higher up in the middle. See there again, it's in the noise. Looking at 800 nanoseconds. These are the individual pulses when it's on steady, and there again the frequency may not be entirely correct. Depends on whether you want to count those ripples at the bottom or not, which you probably don't. The sheets clip into a frame with some nice little plastic clips, and they were easy to take off. And at this point it still wasn't working, so I'm investigating the wiring going to the sign. And the first LED in the chain showed some signs there of some liquid ingress and some rusting under the heat shrink tubing. So I took that off, and actually before I took it off I was massaging the package, and the LEDs came on. So after taking the tubing off, found a poor connection there on the first LED, and just soldered that back together, put some heat shrink on it, and all the LEDs came on steady and stayed on steady. So that was pretty much the problem there. And looks a lot better with the lights off. So this is pretty much what it looks like when it's staked in your front garden. It's got a nice brightness to it. I had a video here from my phone of the sign flashing, but it didn't render very well. So that's what the green square is. Yeah, so that was from my nephew, gave it to me last year to fix, but I only got around to it at the end of this year. But we got that in and fixed for them, a couple of days before Christmas, so that was all good. Thanks for watching.